Hi, VencoreWeather.com, meteorologist Paul Dorian here. Well, the great American solar eclipse is coming on Monday, August 21st. There's been a lot of talk about it, and of course that talk will only become more and more prevalent as we close in on the event time. We'll talk exclusively about that total solar eclipse in this video. And first, let's start off with a current look at the sun. We are currently in a historically weak solar cycle, number 24, and headed towards the next solar minimum. There is one lonely sunspot region right now visible on the sun. There have actually been about 25% of the days this year in 2017 with spotless suns, and that will become more and more prevalent as we head closer and closer to the next solar minimum, probably arriving in the year 2019, maybe 2020 in terms of the next solar minimum. Again, activity has been on the low side over the past several weeks, and we'll of course continue to monitor it. All of this will look drastically different on Monday, August 21st for a brief time as we experience what is being referred to as the Great American Solar Eclipse. Well, there's been a lot of hype about the upcoming total solar eclipse, but there is good reason for that. It's quite rare to have a total solar eclipse in the U.S. that extends from coast to coast. In fact, the last time a coast-to-coast total solar eclipse occurred in the U.S. was 99 years ago in 1918. We actually experienced a total solar eclipse in part of the U.S. in 1979, but that was the kind of turned out to be a dud because of cloud cover. It was in February of that particular year. It was pretty cloudy and damp throughout the totality path, so that was not a good experience in terms of viewing for the last total solar eclipse that was on U.S. soil. Also, this is actually the only total solar eclipse only confined to the country of the United States. Of course, that extends back to the beginning of the nation in 1776. So the hype is well warranted. Again, coast to coast, last time this has occurred was 99 years ago. Anytime there's a total solar eclipse, whether it's in the U.S. or anywhere around the world, it's a great learning opportunity for scientists. For example, the outermost layer of the sun's atmosphere, called the corona, is only visible from us here on Earth during a total solar eclipse. Not even a 99% partial solar eclipse will allow for the viewing of the corona. The sun itself is so bright that it just prevents any kind of view of the corona except during that few minutes of a total solar eclipse. And the corona is very interesting to scientists, especially solar scientists, because it is extremely hot, on the order of 3.5 million degrees, and much, much hotter than the surface of the sun, which averages around 11,000 degrees. That fact has puzzled scientists for decades. How can the corona get so hot? It's analogous to having a bonfire, and the air around the bonfire is much, much hotter than the bonfire itself. Well, this will provide another learning opportunity for at least the viewing of the corona. There are three layers in the sun's atmosphere. The thickest one, the lowest one, is called the photosphere. Then there's the chromosphere, and then finally the outermost layers, the corona. The chromosphere and corona only visible during total solar eclipses. Also, if there happen to be any kind of solar storms during that totality time period, we will see it. We will see coronal mass ejections. We just talked up front in this video about how it's been quiet on the sun. You never know, there could be a solar storm during that totality time period, and if so, that'll give scientists a look that you cannot get except during a total solar eclipse. Meteorologists are very interested in what happens in the totality zone for those few minutes. Experience has shown that temperatures tend to drop 10 or 15 degrees, and all of this is explainable. The sun, of course, once that is cut off, the heating process generally works by the sun heats the ground then in turn heats the lower atmosphere. Well, if you cut off the sun, as is the case during a total solar eclipse, the heating of the ground stops and the lower atmosphere cools off, in some cases pretty dramatically, in that totality zone during that totality time period of a few minutes. Again, on the order of 10 or 15 degrees. Another thing that happens is the winds tend to die down. And again, we're talking about inside the totality zone. The heating of the ground generally produces warm air updrafts, and the mixing of the atmosphere adds to typically increased winds during the afternoon hours. Winds generally stronger during the daytime than during the nighttime. Well, the total solar eclipse kind of fools Mother Nature into thinking it's nighttime, the sunlight is cut off, the heating in the lower part of the atmosphere is cut off, and the winds tend to die down. And the combination of the winds dying down and the birds actually react, again, being fooled as if it's nighttime. They tend to go home to roost, quiet down. So the combination of the winds dying down and the birds going quiet generally leads to what a lot of people have noted, silence during the totality. Again, we're talking in the totality zone. So for those few minutes, temperatures drop, winds die down, the birds go silent, and there's a general silence around for those couple of minutes. Another learning opportunity here is not only the sun's atmosphere, but the Earth's atmosphere. The ionosphere, specifically, way up in the upper part of the atmosphere, is impacted by the sun. There's a process called ionization that has an impact on radio frequencies. And what's interesting is, many of you probably have noticed that during the nighttime you may pick up radio stations from far distances away that you do not pick up during the daytime, and that's because of what's going on in the ionosphere during the daytime. And again, the sun impacts the ionosphere. During a total solar eclipse, you can actually pick up faraway radio stations because, again, it's the atmosphere is being fooled as if it's nighttime. So there will be many radio operators and atmospheric scientists studying this event, specifically with respect to the ionosphere. One final point I want to make here before we move on is, anywhere in the U.S., for people viewing this eclipse, you need proper solar eclipse glasses. Even in the totality zone, evidently it's safe to look at the sun during those couple of minutes when the sun is completely covered by the moon. But just before and just after that, it'll be essentially a partial solar eclipse, and permanent eye damage can be caused by viewing a partial solar eclipse without proper glasses. Be forewarned, there are apparently fake glasses going around. Make sure they're proper solar eclipse glasses. Again, anywhere, whether it's in the partial solar eclipse area, and that includes anywhere outside the totality zone during this eclipse, will experience a partial solar eclipse of at least 48%. But even in the totality zone, you need these glasses specifically for the before and after time period of the totality. So just wanted to make that upfront point, because permanent eye damage can certainly be caused by the viewing the solar eclipse without proper glasses. Well, this is a map that shows the totality zone. It's about a 67-mile path that extends from Oregon to South Carolina. This dark path right here is the only place that one can observe the total solar eclipse. That's 100% of the sun will be covered by the moon in this narrow path, again extending from coast to coast. Hasn't happened like that in the U.S. since 1918. Elsewhere, there will be a partial solar eclipse. Anywhere in the U.S. will be at least 48%. D.C. metro area, for example, is 82% of totality. Philadelphia, about 75%. New York City, 71% or so. Partial solar eclipse in all this other region. The only place that a totality will occur is within this dark region right here. Again, it's about a 67-mile wide path that extends from Oregon to South Carolina. The biggest city in that path is probably Nashville, Tennessee. Other cities include Casper, Wyoming, Carbondale, Illinois, the Great Smoky Mountain National Park on the Tennessee-North Carolina border, will be in the totality zone, as will Columbia, South Carolina. So this is how the upcoming total solar eclipse will fall out on Monday, August 21st. Well, this is an example of an image of the corona, where the corona is visible during a total solar eclipse. It appears as a gaseous fumes, perhaps, or plumes coming off the surface of the sun, ionized gas. Again, the corona is of extreme interest to solar scientists, only visible during a total solar eclipse. In fact, if there's a 99% partial solar eclipse, cannot see the corona. It has to be 100% totality zone, so a lot of solar scientists will be flocking to that Oregon to South Carolina 67-mile wide path in order to be able to view the corona. This corona has puzzled scientists for decades in terms of how hot it gets. It's estimated to get as hot as 3.5 million degrees, much, much hotter than the surface of the sun itself, which is estimated to reach around 11,000 degrees on average. How it gets so hot is still a puzzle to scientists. And let me say up front here that we know a lot about the sun, but there's still a lot we don't know about the sun. And of course, ultimately, the sun is the driver of all weather and climate, so it's extremely important to learn as much as we can. And a total solar eclipse allows a great opportunity to learn more specifically about the sun's atmosphere and how it impacts the Earth's atmosphere. Well, in addition to the corona, if there happens to be any kind of solar activity during the totality time period, again, this is just a brief time period on Monday, August 21st, we will view that. We will view solar prominences, or what is known as a coronal mass ejection. This is an example of a coronal mass ejection. This, by the way, approximate size of the Earth relative to the sun. So any kind of solar activity during this event will give solar scientists an opportunity to view something like a solar flare or any kind of a coronal mass ejection. Again, we are headed towards a solar minimum. Activity has been on the low side in recent weeks, but you never know what could happen on Monday, August 21st. Well, in terms of viewing conditions, it will probably not be known until a day or two ahead of time which part of the country will be best in terms of cloud cover for viewing the solar eclipse. This is a climatological cloud cover map, and areas in blue here are most favorable in terms of climatology with respect to viewing a solar eclipse. In other words, the interior part of the central and western U.S. from a climatological point of view is the best area to go to view this solar eclipse. Of course, that is only climatology. Who knows exactly at this point in time what the cloud cover will be. One of the things we'll be focused on the East Coast is tropical moisture. Tropical season in the Atlantic Basin is, of course, ramping up, and if there's any kind of a tropical system near the East Coast, that could obviously have an impact on the totality zone area of South Carolina, for example, or even inland in areas like southwestern North Carolina or Tennessee. So again, climatologically speaking, the interior west and central part of the U.S. is the most favorable place for viewing, but it won't be until about a day or two ahead of time that we'll have a better handle on the actual cloud situation for that particular day, Monday, August 21st. Oh, well, let me point out a couple of other interesting facts about total solar eclipses. Hundreds of millions of years ago, a total solar eclipse was not viewable on the Earth because the moon was so close. It completely blotted out the sun and the sun's outer atmosphere. Hundreds of millions of years from now, total solar eclipses will not be visible on the Earth because the moon will be so far away. The moon is actually drifting away slowly but surely from the Earth, a couple of centimeters a year. So in hundreds of millions of years, it will actually be too far away to be able to view solar eclipses, total solar eclipses on the Earth. In this current age, we are actually blessed because it's actually a perfect relationship between the size of the moon relative to the sun and the distance of the sun to the Earth and Moon, so that in this particular age, this millennium, the two bodies, the Moon and the Sun, appear almost exactly the same size in the sky, and you'll notice that in the totality zone during a total solar eclipse. So we are blessed in this particular age with respect to the relative size of the Sun to the Moon, and in fact during a total solar eclipse they appear almost exactly the same, and that is certainly lucky for this particular time period. One other thing I like to point out here is a lot of people notice some like dancing around in the atmosphere during a totality time period. Again, only a few minutes where it's 100% covered, but it's got known as the Bailey's beads tend to appear, and that's because sunlight actually shines through valleys on the Moon, and there's some kind of dancing around. It creates kind of the impression of a diamond ring in the sky. So something to look for if you are in fact lucky enough to be in the totality zone. Again, that will only last for a couple of minutes in that stretch of land from Oregon to South Carolina. Final point here, and we've talked about this already, the corona, the outermost atmosphere on the Sun, the outermost layer of the Sun's atmosphere. It gets extremely hot, and that puzzles scientists as to why that gets so much hotter than the Sun's surface. Well, one final map I'd like to show. If you happen to be unable to see the total solar eclipse this time around on Monday, August 21st, believe it or not, there'll be another shot, not too distant future, just 7 years from now in the U.S., April 2024, there will be another total solar eclipse. That one will extend from Texas to Maine. This is the path of totality for the current upcoming solar eclipse on August 21st from Oregon to South Carolina. In April of 2024, there will be another one, another opportunity, and that will extend from Mexico all the way across Texas to Maine. So we're lucky enough to have another chance in just 7 years from now. And the most amazing thing is if you live in the extreme southern part of Illinois, Carbondale, Illinois, for example, you are in the totality zone for not only this 2017 total solar eclipse, but also for the next one. The odds for that are just astronomically against being able to be in an area like that that will actually have two total solar eclipses overhead in a 7-year period. Carbondale, Illinois wins the lottery with respect to the viewing of total solar eclipses. So that's it for now. For VencoreWeather.com, I'm meteorologist Paul Dorian.